Hello dear students, in this class I will be giving a brief summary of bilinear transformation method. The bilinear transformation method is used for the design of IIR filter, that is a digital filter. The advantage of bilinear transformation is its one-to-one mapping. It's one-to-one mapping, or it's also known as conformal mapping. It's conformal mapping. It's an advantage of bilinear transformation. The third point, it's having wrapping effect. Wrapping effect is a disadvantage of bilinear transformation technique or method. Okay. Fourth point, the important equation. We know IIR filters are indirect. Design of IIR filter is an indirect method. First we have to design HA of S, that is a transfer function of an analog filter, and then transform it to transfer function of the digital filter using the bilinear transformation. So here what is the equation you have to use? S is equal to 2 by T 1 minus Z inverse by 1 plus Z inverse. So this equation is known as relationship between to transfer analog filter transfer function to digital filter transfer function. So how can you prove that it is one-to-one mapping? For this there are few important equations to be known. So first is S is equal to 2 by T 1 minus Z inverse by 1 plus Z inverse. This T is known as sampling rate, or it can also be written as S is equal to 2 by T Z minus 1 by Z plus 1. S is equal to sigma plus J ohm, and Z is equal to R e to the power j omega. So these are 1, 2, 3 important equation, and fourth is characteristic equation of mapping is Z is equal to e to the power of st. Okay. Next important formula is, so after substituting we got real part, imaginary part. So sigma is coming to be as 2 by T R square minus 1 by 1 plus 1 plus R square plus 2 R cos omega. Okay. And ohm is coming to be as 2 by T 2 R sin omega by 1 plus R square plus 2 R cos omega. From here we can prove one-to-one mapping. This is the advantage of bilinear transformation. So what it is telling, when sigma is less than 0, that is for in the negative half of the S plane, R will be less than 1, and when sigma is greater than 0, R will be greater than 1, and when sigma is equal to 0, R will be equal to 1. So the left half of the S plane is mapped to the inside the unit circle in the Z plane. So it leads to stable filter, stable digital filter. So one-to-one mapping and getting a stable digital filter is advantage of bilinear transformation. Coming to this one, on simplifying we got the equation as ohm is equal to 2 by T tan of omega by 2. So this results into wrapping effect. This is a disadvantage of bilinear transformation. wrapping effect, or also known as frequency wrapping. So at low frequencies the relation is linear. At high frequencies this distortion is happening. So how the distortion, this is if you see the relation between this is ohm and this is omega, this is a non-linear graph due to this equation. And if you give a magnitude response of analog filter, that is mod of h of j ohm versus omega, if you are giving pass bands centered at same frequencies, it will result to, if you are finding what is the magnitude response of a digital filter which is represented by this mod h of e to the j omega, it will lead to disproportionate pass bands. The width will go on decreasing. This is known as the effect of wrapping on magnitude response. And coming to phase response, this is a non-linear graph between ohm t and omega. And if you are giving an analog filter, phase response is denoted by angle h of j omega. Linear phase if you are giving, it will come to as a non-linear graph. It will come as the somewhat like curved angle h of e to the power j omega in phase response. This is known as effect of wrapping on phase response. Okay, so linear phase response of analog filter is resulting to non-linear phase response of the derived digital filter. So this is due to the wrapping effect, the effect of wrapping effect on magnitude response, effect of wrapping effect on phase response, due to the equation ohm is equal to 2 by t tan omega by 2. Okay. So once again we can write here ohm is equal to 2 by t tan of omega by 2. So how this wrapping effect can be eliminated? By pre-wrapping the analog frequencies. So before the transformation apply pre-wrapping frequencies, that is find ohm p, that is equal to 2 by t tan of omega p by 2. Find ohm s, which is equal to 2 by t tan of omega s by 2. So this is a summary of the bilinear transformation, that is its 1-to-1 mapping is advantage. It results, bilinear transformation method results in a stable digital filter. The drawback of bilinear transformation method is wrapping effect, and it can be eliminated by using pre-wrapping analog frequencies. And the transformation equation is given by S is equal to 2 by t 1 minus z inverse by 1 plus z inverse. You can refer the previous video classes of bilinear transformation for detailed derivation. Thank you. Good luck, students.